Everyone. First of all, I have the honor to present in front of you today my conference paper, which is under the title Optimal Location and Scale of the DG units by using the chaotic acceleration arctangent to improve the PSO algorithm. In the beginning, we start with our work plan. We give a short introduction, then we give the origin of our problematic. Also, we give the results of our study, and we conclude our study and give some future work. The electrical network is divided on three main parts: the transport, subtransmission, and distribution network. Due to the lower voltage at the distribution network, we have a lot of losses. So our study will be focused only on the distribution network. From the literature reviews, we have some authors have chosen to use some optimization algorithm to search the optimal solution of the setting and magnitude of 4 kinds of distributed generation units. Some other authors have focused to make difference between various kinds of distributed generation units, and some other authors have focused to make and to define the impact of the injection of the distributed generation to the electrical network. So our study will be by using an optimization algorithm to inject distributed generation to a network. The origin of the problem is come at the peak domain, where we have the companies work at maximum. It means there are a lot of losses. So this last one gives rise to unnecessary expenses. In this study, we will use the MATLAB software to find the optimal location and size of distributed generation units. The objective function of this study is to minimize the power loss and the voltage deviation of the network. This objective function will be subject to the following constraints: the distributed generation constraint, the voltage limit, the admissible current constraint, and the power balance. The methodology used in this study is to update the cognitive and individual and the cognitive social parameter. Also, we adjust the inertia weight coefficient to update the position of the possible new particles solution. Our algorithm is as shown in the following figures. These figures help us to show the flow chart of our proposed algorithm. To test the performance of our study, we use the distribution network composed of 69 bus. And we will try to inject 2 kinds of distributed generation. Distributed generation that generates only the active power, and distributed generation that which generates both active and reactive power. After implementation of our data in MATLAB software, we have found that the power loss at each node is more improved than the base case by using our method. Also, we have the voltage profile for different buses is more improved than the base case. And the solution is found after 5 iterations. For the second case, it means the distributed generation which injects both the active and reactive power. We find that the same, we have the power loss at each node is more improved by using our method than the base case. And also the voltage profile by using our method is more improved than the voltage for the standard case. And the solution is found after 10 iterations. From this table, we can show the difference between our proposed algorithm and other studies. And it's clear that our proposed algorithm helps to minimize the power loss and improve the voltage profile by minimizing the voltage deviation. So we conclude that our proposed algorithm is performant and more improved than other method. So and we advise to use this method to inject other kinds of distributed generation to the network. Thank you for your attention.